Welcome to The Explainer. Today, we're looking at a fascinating and, frankly, absolutely vital topic. We're living in this paradoxical reality right now. On one hand, our climate is changing in ways we've literally never seen before, breaking records across the globe with these incredibly complex, chaotic weather patterns. But on the other hand, the technology we're using to understand, track, and predict these changes, it's undergoing a total revolution. We are essentially pairing the raw, untamed power of nature with the cutting-edge precision of artificial intelligence.
Okay, let's dive right into our roadmap for today. First, we'll cover a planet breaking records. Then, Europe's extreme climate. Third, the El Niño effect. And finally, the AI forecasting revolution.
Starting off with Section 1, a planet breaking records.
I really want to emphasize this number, 21 degrees Celsius. According to the Copernicus Marine Service, on June 21, 2026, the global average sea surface temperature hit exactly this mark. And listen, this isn't just a warm day at the beach. This is a brand new global record for this time of the annual cycle, completely smashing the previous record set in both 2023 and 2024. What we're seeing here is the continuous, cumulative impact of human-driven climate warming, totally intertwined with emerging natural weather patterns. 6 months of sustained, exceptional ocean warmth led right up to this staggering number.
When you map out these heat anomalies globally, the sheer scale is, well, it's wild. You can clearly see vast expanses of elevated ocean temperatures everywhere. By the end of June 2026, a staggering 82% of the entire global ocean was experiencing marine heat waves of varying intensity. And a warmer ocean means more evaporation, vastly more energy for developing storms, and just intense pressure on marine ecosystems and coastal economies. Moving on to Section 2, Europe's extreme climate.
So according to the 2025 European State of the Climate Report, Europe is actually warming twice as fast as the global average. That makes it the fastest warming continent on Earth. Almost the entire continent saw above-average annual temperatures in 2025, and Europe experienced its second most severe heat wave on record. This intense, localized warming has profound impacts on literally everything, from human health right down to critical infrastructure. And it's definitely not just happening on land. A record 86% of the European ocean region experienced at least strong marine heat wave conditions in 2025. Now, when the waters surrounding a continent get this exceptionally warm, they act like a massive thermal battery. They heavily influence the weather systems that pass over them and significantly disrupt marine biodiversity along the way.
Here is the crucial takeaway. Climate change doesn't just mean everything uniformly gets hotter. It means everything gets significantly more chaotic. Europe is experiencing massive hydrological contrasts. In northwestern and central Europe, you've got extreme dry soil and below-average river flow. Meanwhile, in the southwest, you have unusually high precipitation and major flooding. And right in the middle of all this chaos, across the Iberian Peninsula in Spain and Portugal, these contrasting conditions created abundant dry vegetation that basically fueled record-breaking wildfires. It's this wild paradox of extremes happening simultaneously on the exact same continent.
Which brings us to Section 3, the El Niño effect.
To really make sense of these chaotic regional events, we have to look at the massive global drivers pushing the atmospheric dominoes. El Niño, as you likely know, is a natural climate phenomenon characterized by above-average sea surface temperatures and weakened trade winds over the tropical Pacific Ocean. When this giant pool of warm water in the Pacific shifts, it redistributes temperature and precipitation all over the globe. It shifts the Pacific jet stream, altering weather thousands of miles away, and serves as a primary driver for extreme weather events like floods, droughts, and even tornadoes.
One of the most fascinating impacts of El Niño is how it dictates hurricane seasons, essentially creating a tale of two oceans. In the Atlantic Basin, El Niño actually suppresses hurricane formation because it increases vertical wind shear, basically tearing storms apart before they can even organize. Because of the strong 2026 El Niño, NOAA predicted a 55% chance of a below-average Atlantic season. But over in the Pacific Basin, it's the exact opposite. El Niño ramps up hurricane activity by providing those warmer waters and highly favorable atmospheric conditions. All right, bringing it all together with Section 4, the AI forecasting revolution. So, with the oceans practically boiling, Europe experiencing simultaneous droughts and floods, and El Niño totally shifting global weather patterns, the multi-billion-dollar question is, how is humanity adapting to predict this complex matrix of climate extremes? Well, we turn to cutting-edge technology. But when we talk about artificial intelligence entering the realm of weather prediction, a natural fear always pops up. It poses this huge question: is the need for human meteorologists going away? I mean, if a machine can crunch the numbers better, do we still need human experts at all? The answer is a resounding no. Pedram Hassanzadeh, an associate professor at the University of Chicago who researches AI and weather prediction, states it perfectly. He says, "I think actually now even there is a higher demand for meteorologists. We certainly need experts to be in the loop." You see, forecasting is fundamentally a team sport. AI isn't here to replace human expertise, it's here to massively enhance it. It's bringing computer scientists, mathematicians, and meteorologists together, much like they did during the dawn of the very first computers. And here is the metric that completely changes the game: 100,000 times. That is how much faster these new artificial intelligence models can produce weather forecasts compared to our traditional physics-based systems. By running so rapidly, meteorologists can generate dozens of forecasts in the exact same amount of time it used to take to generate just one. This allows them to dramatically shrink the cone of uncertainty, providing much more accurate probabilities for where a storm will hit or exactly where a dome of extreme heat will settle. But beyond just being 100,000 times faster, this human-tech partnership provides some truly incredible advantages. For instance, AI extends our predictability limit from about 8 days out to 9 days. Now, one extra day might not sound like a lot on paper, but in disaster preparation, 24 hours absolutely saves lives. And think about customization. Traditional models rely on standard data inputs, whereas AI models are highly flexible. They can be tailored with specific regional data to predict highly localized events, like the probability of extreme heat hitting Chicago, or helping farmers track highly complex monsoons in India. So, I want to leave you with this thought. We are undeniably facing unprecedented global climate challenges right now, from boiling oceans to incredibly chaotic regional extremes. But we are also meeting those challenges with unprecedented technological innovation. With AI acting as a 100,000 times multiplier for our dedicated meteorologists, what other complex global challenges can this human-tech partnership solve next? The climate is changing, for sure, but so is our ability to understand it. Thanks so much for joining us for this explainer. Keep asking those big questions, and we'll see you next time.